assistants and Professor Dr. Ahmet Ünveren, Sir Mustafa Çağataylı, and our supervisor Adnan Acar. I would like to introduce myself. My name is Burcu Orhan, and my teammates Ayşe Dilara Öztürk and Sinem Üngetirek. Today, we will explore our project, which is robotic hand control by globe using wireless communication. We have a very busy schedule. Let's start with the introduction part. So, today we will explore this project, which is we combine education and technology. As you all know, these days the main issue is the practical experience. We combine education and technology with a hand of experience to empower the students and providing a technical, practical experience for them. And we would like to train future technology leaders. As a purpose, initiative educational tool that integrates flex sensors, we would like to use we use in the flex sensor to get the motions, and it is via wireless communication. It's sending to the robot, and it mimics to the movements which we have on the globe. And it's be customizable and provide the students accessible platform that offers hands-on learning and encourage the creativity and initiativity. As a program definition, as I told you, right now we are in our graduation project presentation, and even we have some question in our mind. After we graduate, what is going to be happen? We have enough theoretical experience, we have theoretical enough knowledge, but we don't know how we can transfer that theoretical knowledge to the practical experience and practical skills. And when we face in our career life, when we are in the interviews, companies are asking us, oh, what kind of practical experience you have? But when we graduate and when we are having the courses, we are not having that much enough practical experience, and because of this lack of experience, it's an issue to get between theoretical knowledge and transform to practical experience. So our main issue is that what is happening in the future, there will be a gap for the expert of this area, expert of technologies. So we focus that as an STEAM students, how they can improve themselves, how can they exposure the wireless communication and robotic technologies, how they can gain the diversity learning area, diversity learning experiences, and the other issue, limited interactive learning opportunities. We are using sometimes simulators in the labs, but we don't know how can we do them in a real life. And challenges in training future technology leaders. All we are is studying because of becoming a leaders, upcoming this country, other country, all around the world. But if we don't know how we are acting in our field, it is going to be a problem in the future as a leader, as a future leaders, and in the education part. And it will affect also next initiatives and the next generation.
If you want to talk about the benefits of this project, it would be right to put the following in the first place. With this project, we learn to work interdisciplinary. We used our knowledge of electronic hardware and software to make circuit and wireless communication connections of the robotic hand and the globe. And we improved ourselves. In addition, designing this system and making it ready for use has been very beneficial for both our academic and future career goals. Another benefits of this project is that we have improved our creativity and problem-solving skills with this project. We faced various problems from the beginning to the end of the project. We will briefly describe them in the following parts of our presentation. But at this point, together with my teammates, we managed to find a solution to every problem we faced. Therefore, with this project, we managed to improve ourselves in many ways, both in individually and within team.
Hello, my name is Inge. Today I will explain the constraints. Depending on the wireless communication technology used, there may be limitation in the range of the which control of the robotic hand. This limitation is to be total implementation account when defining the intended use of the system. Feature more designed and building the robotic hand within the wireless communication can be technically challenged and difficult. May be encountered implementation and grants from the experience transfer may be needed. And cost, the build of the robotic hand with the wireless control may involve use of the specified components that can be made a project costly. Educational institution will need to consider budget constraints when implementing such project and the functionality. We're talking about the flow diagrams and globe flow diagram. We define the RF module and radio frequency module means for our globe. We record the values range of the flex sensor, and after that we learn the motion current range. This range helps us to adjust our position. We ensure that all data is transmitted to the RF module and the robotic hand reaches the motion data. How this data transfer to servo motor, Lara explained.
This diagram explains the working logic of servo motors and RF module in the robotic hand. The signals received from the flex sensors communicate with the RF module, and servo motors are connected to the Arduino, and the wires received here communicate with the RF module and enable the servo motors to operate. These are tools. We use SolidWorks 3D printing machine and Arduino to develop our project. First, we use SolidWorks, a computer-aided design software program, used to create 3D modeling and 2D drawings of mechanical parts. Next, we use 3D printing, which is the process of creating three-dimensional objects by adding layers of material on top of each other until the desired shape is achieved. Finally, we use System C to run the Arduino manual. And we designed the circuit connections using FreeSync and then started to create the circuit connections of the printed hand.
As a hardware design, as my friend mentioned, we use SolidWorks. You can see our drawing here. We just put the general of it. And when we move to components, we use Arduino Nano. We use two Arduino Nano, two adapter, two NRF 24L01 module. We use NRF, which is RF module, let's say, to make it basic. We use it with adapter because of these RF modules are very sensitive modules and they are affecting any noise. So we use the adapter to just voltage reducing the voltage, and we use servo motor mini as a six servo motor mini, one for this, and for each finger we use one servo motor mini. It's totally 6. And mini breadboard, we use 6 flex sensor, one for wrist and 5 for flex sensor, and we use 10K resistor and potentiometer. We use potentiometer because of that. The issue is while we were testing, we realized that the RF module is have an issue because of the noise of the signals. So we just use the potentiometer to make it 5 voltage stable and sending the messages in a very stable way. We use PCB cards, jumper wires, and DC to DC converter. We connected DC to DC converter as a step-down converter with the potentiometer.
two pages, transmitter and receive pages. Transmitter we used for globe and receiver is the robotic hand. Transmitter used totally 85 lines of the torso. And the receiver is the 112 and next implementation please.
The images you see in this section show the stages of implementing and testing the parts we printed. First, we correctly join the parts we obtained from 3D printing. Then we place the motors in the robotic and create it. We made the circular meshes of the Arduino we use and the cable connections of the hand we created. At this stage, we tested whether the motors were working or not with a simple test code we prepared. After this part, the robotic hand completed, we started to create the globe. First of all, we correctly connect the flex sensors that will allow us to receive motion signals to the globe. Then we made the circuit connections required to connect to the Arduino in order to understand whether the flex sensors are working or not. We created a simple test code and tested it. Finally, we properly connected the wireless module, the RF module, which will enable the hand and globe to communicate. After the connection process was completed, we wrote another test code. These are our test codes. This is for our servo motors test codes. We attached each servo motor, and in this section, we try to understand our motors are clearly working or not. And this is our flex sensor test codes. These are our RF module test codes. One of them is for globe transmitter, another one is receiver for printed hand. And these are our testing parts. In this part, we can obtain flex sensors motion signals directly.
Okay. Beginning of the journey, we thought like, okay, we can make this hardware project under $200, but we faced that it's not possible actually. About $400 we spent, and when we convert to Turkish lira, it's about 12,000. And I would like to say we have a 3-time 3D printing. We are having a huge issue in the 3D printing part. Sometimes design, sometimes the printing quality, sometimes the filament quality is affecting our movements even in the hand. And the hardware components, day by day, it's just increasing the cost. Before we finish and make the conclusion and move to demo, we would like to say our failures and achievements in this project. We started with huge expectation and big hopes. But in the end, we realized that we have some failures and we have some achievements, and we would like to share that in an honest way. So, we have failures in design problems due to the experience during 3D printing, as I told you. We spent about 2,500 TL, but in the end, it's affecting from everywhere. Like our filament quality, it's affected affected by our printed way, who printed, and etc. etc. Cost achievement, it was our failure. We hope that we can achieve that to less than $200, but we, in the end, journey finished as a $400 sorry. And the component supply, which is, we are living in Ireland, and it's very hard to find some components. Like we just sometimes we broke our motors, sometimes our RF module giving an error, and in the end it was so hard to find, and we couldn't provide provide somehow. As a power supply issue, we thought like when we use adapter with RF module, it will fix the noisy problem in the signal, but it didn't happen. And we calculate that, okay, we can just use for 3000 milliampere, 3.7 volt lithium battery. It will work regularly and simultaneously. But in the end, our power supply didn't become enough. So we are taking some power from laptop, some power from battery. In demo, you will see that. But I would like to say our achievements. Actually, to be honest, but we realized that having a hardware project is hard to deal with, and it's a challenge accepted for us. So we worked on it. Mostly when you are visiting the forums, you will see RF modules are giving the error to sending messages each other. But we fixed that. Right now, we're sending the messages simultaneously. And we use DC to DC converter, reduce voltage, and arrange the RF module signals, and it also fixed it in the end. And power supply issue, somehow we are using the computer power, and it's fixed also. And using the theoretical knowledge and a practical experience, I would like to say that in this whole my university life, okay, I realized that I have all theoretical knowledge, but I didn't realize, I just realized also I didn't enough practical knowledge. And in this project also, me and my teammates, they just how can I say, explore themselves. We are here and we can do this kind of projects. Yes, it's not easy. Yes, we don't have enough practical knowledge, but in the end, we can achieve that. Let me move with the conclusion. Yeah, so as a conclusion, we can say this project you can accept as a version 1 of the combination of education and technology, and we can use that to educate STEAM people, engineering students, or technical high school students to gain a practical experience. And if you would like to encourage the other people, the next generation, or encourage also ourselves to do version 2, and we share the failures and achievements to take a baseline reference to put a new milestone of this project. Thank you so much to hearing us. Lesson with the demo. Thank you. Can we take you to the table so it's hard to read that? Oraya geçmemiz biraz hızlı olacak. Eğer buraya alabilirsek çok mutlu oluruz demo için. buradan da takip edebildiğiniz gibi teknoloji endüstri içerisinde değerleri alıyoruz. Motorlarda bir tendon kısmında aslında problem var. Burada dediğimiz gibi motorların kuvvetiyle alakalı hiçbir problemimiz yok. Fakat dizaynda siz de fark edersiniz ki elinizle bile hareket ettirmeye çalıştığınızda bir sertlik var. Ve bunu torpil edip yağladık, hepsini gördük. Ve zamanla zaten bunlar esneklik kazanan materyaller. Dün tekrardan sıktık, hani daha iyi hareket alabilmek için. Ama yine günün sonunda bir esneme payı oldu. Ama en sağlıklı hareketi serçe parmaklarında. O da hem dizayndan kaynaklı olarak bence bahsedebiliriz. Evet. Bilekte de çok iyi aslında karşılık kalıyor.
Kısmını çalışıyor, işte bu bağlantılar yapıyor, şunlar zaman bir şey ama...
Ama yine de ana hedeflerimizden biri araç o sinyalleri aktarabilmekte. Günün sonunda motor aslında buradan aldığı bütün veriyi burada takip edebiliyor. Evet, versiyon 1 olarak kabul ettiğimizde biz kendi açımdan ve teknolojisinden diyebilirim ki bence başarılı bir sonuçtu.
Çok şey öğrendik ve aslında çok şey yaşıyoruz biz bunlarla.
Yes, please.
I told you.
Nasıl rekasında olduğunu görüyoruz. Rekasında şu an hepsinde
Radyo frekans, RFA dediğimiz şeyleri...
115 olarak setlemiş olmamız gerekiyor.
Evet, şurada 0 kere çarpı dediğimiz orada adresimizi, data adresimizi orada belirledik. Her ikisinde de aynı datayı kullanarak adresleri belirliyoruz ki iletişim ancak bu şekilde sağlayabiliyoruz.
rekası size yapıyor.
Evet, güzel.
Sonuçta hiçbir için bunlar uygulama olacak falan bir de karışmayacak.
Evet. Frekansları, adreslerini biz ayarladık. İletişim konusunda daha iyi olsun diye. Bir de flex sensörlerimizin map ayarlarını da tek tek rotate'lerini biz ayarladık. Önce testing bittiğinde aslında amacımız şey bizim, test yaparken açtığında biz kaç boyu alıyoruz, range'imizi nasıl alıyoruz ve bunu kapattığımızda ve bütün hareketlerimizde kodlarımızda da buna göre map ve position şeklinde şeylerimizi yaptık, değerlendirmelerimizi yaptık. 550'de dururken 800'ümüzle hareketimiz aslında pozisyonumuzun değiştiğini o aralıkta belirtiyor bize. Böylelikle de flex sensörümüz de aynı zamanda servomuza güç vermesini sağlıyor.
Peki mesafe ne olabilir en fazla?
Şöyle, eğer altern kullansaydık bu kilometreye kadar çıkıyordu. Fakat bu modüllerde 100 metreye kadar, açık alanda 100 metreye kadar kapsayıcı var.
Son soru. Sunum başlığı da inovasyon ve yaratıcılıkla alakalı hedefleriniz. Bu projede inovasyon ve yaratıcılık konusunda katıldınız değil mi?
Bence dizayndan bahsedebiliriz. Yani ne kadar çıkan sonuç istediğimiz gibi olmasa da burada bence bizi iki şey failure'a uğrattı. Biri dediğim gibi bu daha farklı bir materyalden yapmaya hedefledik. Hani hem çok fazla esneklik kazanmayan ve daha sıkı çekebilecek materyali bulmakta zorlandık. Bir de 3D printing'in kalitesi bizi zorladı. Ama onun dışında genel olarak işte yani şunu söyleyeyim, bence biz bir sonraki generation'a örnek olacak bir şey yaptık. Yani bir sonraki generation gelip geçenlerde böyle bir hardware projesi yapılmıştı ve bunun iki yazılım mühendisi öğrencisi, bir bilgisayar mühendisi öğrencisi yapabildiyse demek ki biz de bunu yapabiliriz deyip bir örnek olduğumuzu düşünüyoruz. Aynı zamanda da ekip arkadaşlarımla bence genel olarak işte ilk başta gördüğünüz kablo yığını görseydiniz de sonra onu ne kadar azalttığımız, daha basic hale getirdiğimiz bence inovasyon taraflı küçük de olsa katkıda bulunduğumuzu söyleyebilirim. Çok teşekkür ederim. Sağ olun.
Okay, now the second group, I will be in silence.